Landboards presents Debugging FTDI Interfaces. FTDI boards convert USB to TTL serial. These boards have a 6-pin connector with a standardized pinout. Using these cards can be difficult since oftentimes the interface is an all or nothing in terms of operation. A common kind of a problem is swapping of transmit and receive lines. Another common problem is understanding and dealing with hardware handshakes. Isolation of power between the computer's FTDI interface and your target is an important issue as well. This video describes some solutions to these common problems. One useful solution is to have a breakout board to connect and disconnect the various lines. Here at Landboards we came up with a simple card to help in debugging. The card has two 6-pin connectors on either side of the card and a 2-row header in the middle. If you want to connect a pin from one side to the other, all you have to do is install a header. If you don't want it connected, you remove the header. The wiring on the bottom side of the card isolates the two FTDI interfaces from each other and allows them to be connected through the header. Here's a diagram showing the master and slave side connections of the card as well as the jumper block in the middle. One side of the board connects to the target and the other side to the FTDI interface card. The pinouts of the 6-pin connectors and the headers match the FTDI cable, which is also color-coded. It's very important on an FTDI card to know where the power and ground pins are located. The FTDI interface card outputs voltage, and the voltage level is either 3.3 volts or 5 volts and is selected by a voltage select header. This header performs two important functions. One is that it selects the output voltage level that will be on the VCC pin, but equally and in some cases more importantly, it selects the voltage levels on the other pins. This jumper must be set to match the operational voltage of the target. The transmit and receive pins are referenced with respect to this part, so the part itself in the card transmits on the TX or transmit pins and receives on the RX or receive pins. A common mistake is to have transmits hooked together and receives hooked together. To fix this sort of issue, remove the shunts and verify with the scope, if you can, that the transmit and receive pins are on the sides that you think they're on. This usually does require handshake to be working or turned off. In PuTTY, handshake lines can be set to none, X on X off, which is software handshake, to use the RTS-CTS pins, or the DSR-DTR pins. The hardware handshakes are located on these two pins. One of them is a signal that goes out, and the other is a signal that comes in. To debug the handshakes, remove these two jumpers, the 2nd and the 6th jumper. Adjusting the handshakes may require that you play with the PuTTY configuration or whatever terminal configuration you have. Debugging here follows a similar methodology. You may have to jumper on both the target side and on the other side. Oftentimes you can do a loopback on both sides of the handshake line and things will work, but they don't work when they're crossed. Sometimes you can debug these lines with a voltmeter since they are not quickly moving like the transmit and receive lines are. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.